Hey guys, James here. What's up? How you guys doing? Today in my video I wrote down a quote, but this is not the actual thing I want to represent in my video. This is just something briefly. It popped out a few minutes ago in my head, and it's about image. For me, an image means nothing else than a replica or an accumulation or a bundle of information, data, attributes, or properties or characteristics of the original. For instance, if you make a snapshot, a photo with your smartphone of a flower, of a beautiful flower or a tree, but the image is not that moment you captured. The image is the properties of the tree, the characteristics of the tree, the attributes of the flower, the properties of the flower, the functioning of a flower, the functioning of the leaves, the functioning, all that is the image. And we can use that accumulation or bundle or information of that image and use it to explore unknown things. So we have dozens of images we can use to unexplore unknown things. So it's not a bad thing, because I'm saying this because a very old, as we all know, is that God has made man in His image like, and that is nothing bad. It's nothing bad about it. That means just that we have a sort of information, attributes, properties, characteristics of the originator, which we call God, so to speak, right? There's nothing bad about it. Maybe it's just He was giving us good information to move forward, in our whole lifetime. And I don't want to go in the religiously field. I'm talking in general, about mankind, Okay, so that's it. So I hope you guys got it. Okay, that's what it means for me, image. Okay, today I learned about it. As you guys know, I'm studying right now on MIT online about astronautics, and astronomy and aerospace. And today was the topic was about changing orbital altitude and inclinations. That means that when we circulate the Earth, right, and we want to go out of the gravitational Earth orbitation, we have to increase energy to get out of this circulate gravitational orbit to go further away, right? Because the Earth gravity tries always to get close to bring you back. So we need energy to increase the velocity that we leave the gravitational process in the Earth orbit. So let me just draw it how it actually looks like. Let's say this is the Earth, but I'm just telling you that briefly because what I want to actually show you is the geometry in it. And as you guys know in my previous videos, it's geometry. Geometry is the gate between the invisible and the visible. So let's say this is the Earth, right? And we have here a circular orbit that goes around the Earth. And as usually we have satellites that's flying around the gravitational Earth, etc., right? So now, when we want to get away from this field here, because this is the a strong gravitational field of the Earth's orbit, we want to increase with fire, to increase the potential energy to get out of this circular orbit into elliptical orbit, which looks like this. So if the satellite or if the rocket or whatever is right here in the closest to the Earth, we want to put energy so that the satellite or the rocket goes out of the Earth gravity field, and it looks then like this, right? So it goes out like this. This is the satellite. Right? So this is a circular orbit, and this is an elliptical orbit. That's why we say that our planets and the solar system works in an elliptical altitude, etc. So that means that when we increase here the potential energy in the velocity, it will increase the velocity, and that means when the energy increases, what is this that increases? Well, when we increase here the velocity energy, it increases the size of the orbit. So instead of circling around here, which is closer to Earth, we get further away from the Earth, right? Also is when the orbital object, whatever it is, gets closer to the Earth, in this area, it moves faster. When it goes this far out, it's slow. And I want to get to in this thing of perception, optic perception, because it's obviously for me, if you look something in a very far distance, right, that it's hard to let me find the right words. It's harder to recognize when something is extreme far away. You cannot really recognize or capture if it's moving fast. It feels like it's there. It's like if you look something very far away, it looks like it's moving actually slow, right? But if something is extreme near to you, it moves fast, because let me draw it in another way. So this is you, right? When you look something in this direction, that's you. You look over here, and this here is far away, and this is close. So this gives you this optical illusion, perception, that this goes slow turning around. It's like when you look at the sun, the sunrise and the sunset, it takes long when it's sunrise, when it rises, and the sunset, it takes long. It gives you the feeling of long hours, because it's further away, right? The distance, it gives you the optic perception that it's moving slow. But if something is extreme, that's the furthest distance, and this is the closest. If something is moving right in front of you, let's say a fly or a car or whatever, it feels like extreme fast. So that's what I'm trying to similar to see it in that. So when the velocity is increased on the satellite or the rocket, to increase the orbital elliptical because it becomes elliptical, not circular. When it comes into the elliptical orbital range, right? When it's the farthest away, it's slow, right? Remember I was telling you? But he didn't say that. That's what I just discovered. That's the similarities. That's the minimalistic understanding. So if you look here, the object is here, right? That's a human, but it's the planet Earth. And you shoot the satellite around, it takes longer time to circulate over there because it gives you the optical perception, it goes slow. Same like here, you cannot really recognize if it's fast or slow. But if this is very close to the Earth, and we look it from this way now, it feels faster. So it goes like this. And same thing here. So when I saw that, this is what I added on. It's the same thing with optical perception from a human eye and the orbitals thing. But the other thing is, when this is the Earth, this is geometry, what I have discovered. So if this is the Earth, its circular orbit, the gravity, the gravitational field of the Earth. Now we're shooting it out, right? That's the elliptical orbit, right? It's wider. So when you look at that, I instantly see pure geometry, and I tell you why. Let's say, and this is how it works in space, right? Astronomy. Now, when you look at that, right? And let me show you now my geometry. Let's see if you, let's say this is 4 centimeters from here to here. 4 centimeters, right? And this represents this. This is the planet Earth. That's the gravitational field, right? So this gravitational field is this. So, and I add numbers on it. So this is 4 centimeters. The Earth is the half, right? So that is, let's say, 2. This is then 2 centimeters. Let me do it like this, so it's better to see it. So this inside is this black dot. That's the planet Earth, and this is, in this example, the planet Earth. This surrounding is this gravitational field of the Earth. All right. So that's the Earth. This is 2 centimeters. This is 1 centimeter. This is also 1 centimeter. All right. So this is the velocity when it goes in the elliptical form, right? The satellite. This is the elliptical, and this is the circulate orbit. So this is the Earth. This is the circular orbit, which is this. Now, when we increase the velocity v to extend, to increase, to make the orbital bigger, right? The size of it bigger, because it's wider than this, means actually it's nothing else in geometry what they're explaining. So this is the Earth, this is the gravitational field. Now let's say the gravitational field is 4. We take the half. This is 2 centimeters than the Earth, and it has on both sides 1 centimeter, 1 centimeter, and altogether is 4 centimeters, right? Now when we shoot something in here, right? It's just actually nothing else than, so to speak, like this. So this is then over here. It's like an image. This is the 2 centimeters, and this is the 1 centimeter. But this is the image of that. So this is the original, right? So when it orbits around here, you don't see this in here, but it is actually like this, right? It's just a replica, so to speak, an image of the original when it goes this way. Maybe, because it has to be elliptical. Let me try something. Try something like this, so to speak. But this doesn't exist. This is just the image of the original, right? Which you see here. You don't see that here. This is the Earth. This is the gravitational field. It wants to leave the gravitational circle orbit field, so we increase the orbit far away. And if you look at it, it's just like you have two things in one. So this is one, right? So it is elliptic. This, if you see this is an elliptical orbit. It's actually just like 2 circulate orbit, right? But this is not there in here. This is what I mean by minimalistic understanding, right? So I hope you guys get it. I wish you a good night and see you next time. Thank you for watching. Trust me, guys, it's all about geometry. Using your optical perception to understand things. Thank you.